Welcome. We're going to talk about a new chip. And as you can see on the screen, it is CHIP-47 NFC offer data from our very own Clyde or Brandt.
Hey all. Yep, you might know me by Brandt, you might know me by Clyde Wallace. Those of you who have known me for a few years, you'll know that during the 168-hour space, I spoke a lot about supply chain management via NFTs. And one of the cool things that I was thinking about is that you can actually track different products and track where they're going throughout their phases with an NFT that is tied to an NFC in some way, shape, or form. I've been following along with that idea, keeping track of like digital product passport information and also looking at the technical side of things to see, okay, technically, what do we need to do to support this kind of thing? So you'll notice things like CHIP-15, which allows you to add a bunch of extra metadata. You could use that for things like digital product passport information. But this chip is focused on the actual tech side, on the hardware side, if you will, to say, how can you connect a physical item to a digital item? And this solution utilizes NFCs, so you can write your NFT data and even optionally a offer file directly to an NFC chip, and then read that data into a wallet and be able to act upon it. The one thing that this chip does not cover is utilizing that NFC for signing of the NFT itself. So you're going to have standard custody of the NFT, and the NFC is just kind of a information platform for the NFT info. That being said, we'll go ahead and dive right into this guy here. The main purpose is to standardize what information you can read out of those NFCs, just so that any wallets who want to integrate NFC based NFTs and offer files into their wallet, they can, and they'll have a streamlined, standardized way to do so. So this is NFCs. For those who don't know, they are near field communication, essentially a small chip that allows you to read data from it and you can write data to it. They can be in a card format, they can be in a little coin format. There's a lot of different formats these come in, but the core is that it's a chip that stores data and there are standard ways to read and write. The real motivation is that standardization. We want to make sure that there is consistent data storage across these different implementations. There's compatibility between different NFC readers and writers, and that kind of leads to the need for version control and versioning within these. There's established security protocols for physical NFT handling. So as I mentioned, this one's just covering the actual data side, but somebody could come up with a cool solution for utilizing the NFCs to actually sign on behalf of the NFT and do kind of a M of N signing within it. This chip doesn't cover that for really the big reason is availability of signing capable chips that would work with the Chia blockchain. Everybody knows that Tangent is out there. That's kind of the main one right now, and it has about a 20-year lifespan for those who didn't know. But it's kind of tough to source those chips that will actually perform signatures which will work on the Chia blockchain. And that would have to be a SecP or a BLS signature. We have a couple of other operators that are coming into play now, but those are kind of the main two we would be looking for. So in the future, you might see me create a new chip once we have something that can sign. The other reason for this is enabling the interoperability between the applications and the display services. So making sure that if I have one of these NFCs, I can scan it into a wallet and it's good to go. Maybe that wallet will point me to the browser of Mint Garden or Space Scan or Dexy to be able to look at an offer file or look at the NFT itself for further information. And then also we want to prevent the fragmentation of NFC implementations. We want to make sure that there's a common place to at least get the standards. So you'll notice that there is a versioning system in place here so that people can create their own versions of this standard to store their own data, have the offer file be different lengths, all that fun stuff. But we want to make sure that we don't have a whole bunch of radically different implementations out there that wallets would have to adopt. The benefits to this are that physical digital bridge, an enhanced user experience, and also developer support. So you want to make sure that you can utilize these physical assets in the digital world and vice versa. You want to make sure that that interaction is very seamless for the end user so that they're not worried about what wallet do I have to use that accepts this specific NFC? What do I have to do in the future for getting my offer file off my NFC? Or what if I get swag and I want to get the NFT for that swag? Kind of like the proof of attendance badges or proof of attendance protocols. And then, of course, the developer support. Having a standard, make sure that there's clear implementation guidelines, there's a standard approach to future development, and there's also reduced complexity, say, while it's trying to adopt this technology. I've touched on a couple of the use cases, but to highlight them again, you have things like trading cards. You can have a physical trading card that has an NFT twin, digital twin. Same thing with art pieces. Maybe it's a digital twin, or maybe it's more of a title or a deed, if you will, that you see with a car, where it can show that entire lineage and it's tied to that art piece, but it's the new ownership certificate that you get. It could be luxury products that have that digital twin, or as I mentioned, it could be POAPs. And then you have authentication. So as I mentioned, future implementations might do actual on-chip signing. This one's more of product authenticity via the NFC stored NFT ID. So it's just the NFT store ID that's stored on the NFC currently, and you can scan that NFC and it can pull it up. This chip also covers locking the NFC so that people won't be able to edit it after you ship it out of a manufacturing plant, so you don't have to worry about people messing with things. That ownership validation, it essentially just allows you to tie that physical product to that NFT. So then we get that huge lineage of provenance that you get from standard Chia NFTs. And same thing with transfer history tracking via the blockchain. So it allows you to take that digital world, combine it with the physical, and do it in a more seamless means. Now, I know a lot of people are interested in gaming and interactive experiences, so you might see some implementations along those lines from the community, like physical digital hybrid games. I know Cass was really big into the ferry doors, and you could walk around and find ferry doors and scan a QR code to get your NFT. Well, this is a new way to do that, where you would have an NFC in there rather than a QR code. Uh, Interactive art installations, same type of thing. Instead of scanning a QR code, you can walk up and tap that NFC. You'll find that NFCs have varying lengths and degrees of readability. So you can actually get an NFC that's readable from, a foot away and have that interactive art installation as you're walking by ping people's phones. And you can create a whole interactive experience in that regard. And same thing with that event-based NFT activities. We've seen a lot of different like scavenger hunts that are created inside the real world, and they tend to focus just on the digital side of things right now, where you play along on your phone and you're doing all this stuff digitally. Now you can make a lot of that physical. You might have a physical scavenger hunt where you're finding items, and the way that you register, yeah, I found this item, is by scanning that NFC. The technical feasibility and really the focus of this is the widely available NFC tag types. So wanted to make sure that the NFCs covered inside of this and the methods covered inside of this chip are widely available, that people can start using them today and start using them en masse. And that's kind of why one of the main things I cut out is the ability to sign. I also ensured that this uses standard NDEF message format. So this is the same message format that you'll use for the majority of NFC applications. And there's a lot of tools out there to read and write this type of data outside of the reference implementations I have in this chip. So you can use an app on your phone, such as like NFC tools. They also have a desktop app, and that'll allow you to read and write these NDEF messages. There's also very established NFC protocols on which we're relying upon. Some of those are going to be the NDEF messages. Others are going to be how the cards are actually structured, plus what data can be contained in them, and your space limits within those NFCs. And then you have the existing NFC reader infrastructure. There's a lot of NFC readers out there. You might find USB-based ones that look like this right here. You might also notice that pretty much every smartphone now is an NFC reader already. So there's a lot of ability to interact with users directly with the devices they have. And then they have current NFC security measures, such as the locking mechanism that we'll discuss later here. One key focus is backward compatibility. Part that I didn't discuss here is how that offer file is going to be stored on the NFC. The issue with offer files is that they're very large. I'm sure everybody's seen that offer blob, which can be, 100, 200, 300 characters long. It's rather large. You don't know how large it could be because that's based on the offer itself. So that offer blob can grow, it can shrink based on what's involved in the offer. That means it's not ideal for storing the data on an NFC chip, which has a very fixed limit of storage. To work around this, I spoke a lot with Steve, who is a community member who created OfferCode.d, and it's a offer code shortener system that allows you to take that entire offer blob, shorten it into his is a 5 character offer shortcode, and we're actually utilizing a 64 character offer shortcode, and I'll get into the reason why here in a moment. But utilizing offer shortcodes not only drastically reduces the amount of data that needs to be stored on the NFC chip, but it also enables it to be a deterministic amount of data stored on the NFC chip. And that's very key when you're trying to read and write data in a standard method, is ensuring that you have deterministic data that you're reading from, or at least deterministic lengths, so you know what to expect. Now, back to the different design decisions throughout this. The offer shortcodes, as I mentioned, is for the size of the data. And instead of using the 5 character version, or sorry, instead of using the 5 characters for the offer shortcode, we're using 64 characters. The reason for this is to protect from grinding the codes and to prevent collisions. One of the use cases that the offer shortcodes could be used is single-sided offers, where anybody who has that offer file can accept it immediately. To prevent somebody from grinding through those codes, stealing NFTs effectively, we want to use something that's a little bit longer, has a bit more entropy involved. So we went with a 64 character, 32 byte code. To help differentiate between different implementations, I've added in a protocol version identifier. So it's a 5 character version identifier that people can add and say, hey, look, here's my 5 character version identifier. This is how I'm storing the data. Maybe they have a different character length. Maybe they change the type of data that's involved. But this will allow anybody who wants to implement NFC-based data to provide their spec and allow wallets to adopt it. And then, of course, the security for offer shortcode API. So instead of using offercode.d, we at CNI, if we do plan to do something like this, we're going to have our own implementation of an offer shortcode system for 2 reasons mainly. One, we want to make sure that anything that we create that goes through the system would be done in a secure manner and only done by people who have access. So only CNI uploading effectively would be that. This will also allow us to enforce different rate limits on requesting the offers. Plus, the other main reason is the backend storage of the offers itself. As I mentioned, one use case for this could be single-sided offers, and that means you're putting a lot of trust into whatever system is creating those offer shortcodes. If that system gets hacked and you have a whole bunch of single-sided offers, somebody can go out and take those. So in the future, when you do have on-chip signing via the NFC, you can actually work around that issue by ensuring that that NFC will sign for that offer file to be accepted, meaning you have to have the physical item get the digital. That's out of scope for this, but it's a good look towards the future. And then the specification itself. So this is some reference specs that you can look at. We have the actual NFC offer repo on the Chia GitHub, and this is showing how you can read data and write data on those NFCs. It goes through the entire process of getting a CSV file that contains your NFT information, your offer shortcode, allows you to scan in all of your NFC UIDs so you can prep things ahead of time and then you can actually distribute on demand. So you can prep a CSV file ahead of time that has all the information you need, put it in a secure location, get it out when it's ready, and then just write the data at the time you need to write it. This is a good security enhancement to make sure that you don't have a whole bunch of single-sided offers sitting around on NFCs that somebody could just grab an item and take that NFT from. The other reference that we have is the offer shortcodes repo. So this will be very similar to the offerco.d repo that Steve provides for free. However, Rigidity went ahead and took the time to rewrite in a different language for us, and we have a slightly different methods as to how we're running that API. But you'll find it's very similar. It accepts a offer file and it spits back out a offer shortcode. Now to the offer shortcodes themselves. When you're looking at the offer shortcodes that CNI might host, we are utilizing the deterministic SHA-256 32-byte hash of the offer file. So this means that anybody out there who has the offer file can actually recreate the offer shortcode itself. You can't go the other way. You can't go from the offer shortcode to the offer file unless you have a system to ping it because it is a hash. So we have a quick method in here to show you, hey, look, this is how you can post the actual, or yeah, uh, utilizing a post command to download the offer file based on the offer shortcode. One note on this actually is that if you are a wallet out there that wants to integrate the offer shortcodes from Chia, you'll notice we put in a couple of nice little nuggets like the actual URL here, how to actually retrieve it, and you can integrate these or start to integrate these today if you had wanted in case something happens down the road here. But this would be pretty much all that a wallet needs to do in order to go from the shortcode to the actual offer itself. And then you have the actual NFC offer data. So we talked about the shortcode, how you go from the shortcode to the actual offer data, but how do you get that shortcode? And that's going to be from the NFC. This is kind of the meat and potatoes of this chip, is the spec on the NFC itself. So you'll find a lot more ingrained information within this section. We do have the payload format, so it has that 5-character version identifier. It has the NFT ID itself, and then it has the offer string variable. The nice thing about this is that it's all deterministic, so you know the first 5 characters is the version, the next 64 characters is going to be the NFT ID, and then all the characters thereafter are going to be the offer string. When I say all the characters thereafter, we wanted to make sure this was backward compatible. And that means not just for our 64-character offer string implementation, but we need to make sure it was backward compatible to a 5-character string as well, or for other implementations people use. So you'll notice that the actual length of the offer shortcode is variable. That one's not deterministic based on when you're reading the NFC, just so that you can interact with the different standards or implementations that might exist in the future. If somebody does want to implement this and use something rather than the 64-character string, I just recommend putting in information as to, hey, here's my version identifier. This is the offer string length that I'm going to be using. Make it so that the wallets can know, and you can add that as errata to this chip or ping me and I can help you get it added as well. Now for the actual message structure itself. As I mentioned, we're using the standard NDEF messaging. So you have the standard framework that you would see anytime you're interacting with an NFC. Couple of the main things that were design choices, which kind of increase the bloat, is ensuring we have the actual language code associated so that when it's being read, you can identify, hey, what language do I need to read this in? It's not really pertinent to this specific use case of it, but it just helps the readers themselves identify what type of data to expect. One of the other things that's a little more important, though, is the type T text record. And the reason that we included the actual text record type, or sorry, the type of text record, is that if you want to use a non-reference implementation and you want to use just a standard NFC reader, that NFC reader needs to know what it's looking for. If we don't have the actual type in there, it can really confuse that NFC reader. So having that type allows you to use like NFC tools to scan any of these NFCs and read in human text that entire message structure. I go in a little bit more about the actual memory layout here as well, just kind of help people realize this is what the NFC standard is. These are the different commands that we're using to read and write. If you have any questions or need help on an implementation, don't hesitate to reach out. Always happy to help out. And then the first focus of the tags that I looked at were primarily the NTAG versions, so the NTAG 21X series, 213, 215, 216. I added in ultralight just because honestly, I had a couple of the chips lying around and I wanted to test them out. However, I want to point out one big caveat with the ultralights. These will not work with iOS right now unless you have a very new iOS device. For some reason, Apple just didn't add support for ultralights until very, very recently. So I recommend avoiding the ultralights and sticking with something like a NTAG 213 to keep it really cheap. You can go with, one of these other a 215 or a 216 if you need a larger size. So you'll notice you do have a max size, and this is the actual storage size in bytes. With the current reference implementation I have above, with 64 character as the offer code, you would need something like the NTAG 213, and the ultralight would be too small of a storage size. But you can obviously see that you can pack a lot more data than what the current reference implementation I have shows. Something like the 5 character limit will fit inside of the ultralight pretty well. And then as you dive into those different repos, you're going to find that there's a few different operations that you go through. When writing, you need to actually detect the tag. You want to read its UID so you can verify, hey, this is an actual NFC. I'm not being spoofed. You can identify the tag type there directly as well. So you can identify if it's 213, 215, 216. And then you can verify that it has sufficient memory for whatever it is you're writing. You want to make sure that you format the data properly, add all the additional info, such as that text record identifier, and then add that TLV wrapper. Those are just the things that make sure, hey, look, this is an actual NFC record. I can read it properly. All those actual specs are in that above section if you do want the technical details. And then, of course, writing it page by page, very basic process. Really, this section here goes over the basic processes associated with reading and writing NFCs. But because this is new to the Chia ecosystem, I wanted to make sure there was some high-level reference to it. Read process, somewhat similar. You can read the tag UID, identify the tag type so you know what data size you're looking at, you know what blocks you're looking at. And then you can read the message, verify the format, and extract that payload. Now the fun part though, this is the data parsing. Generally, I just skip those headers in the language code. That the headers, the TLV, and then it's also the language code, and it's also the text record identifier. You can just kind of skip those at this point because your system is expecting this data. However, you could utilize those if you needed. Then you would extract the version, so you know, okay, this is the implementation I'm working with. Then you would extract the NFT ID. Now, depending on the wallet or the end use case, maybe that's where you stop. Maybe the entire purpose is so that you can scan it, get the NFT ID, and see, does the digital twin match the physical item? Other implementations might go to the next step, and it's the rest of the data is going to be the offer string. And more than likely, it's going to be an offer shortcode. Our implementation is 64 character, but as mentioned, offer code ID could be a 5 character section there. You can parse all that data and say it is an offer. You might go through the offer code shortener system in OfferCo or Chia in order to get the offer itself to display to the end user. So a lot of use cases from just displaying data to actually accepting offers directly from these things. And then, of course, the lock operation. This is really big to make sure that nobody messes with that data that's on the chip so that nobody's stealing offer files, changing things, adding malicious data without you recognizing. A lot of good reasons for that. This is optional inside of the reference implementation I created. So as you work through the commands, it'll prompt you and say, hey, do you actually want to lock this NFC? One big note here is if you do lock it, that does mean it's actually locked. It's read only, it's permanent, cannot be reversed. You don't really want to try to accidentally lock one. So use that with discretion. Make sure you're all ready to go before you lock a chip. And if you want to test locking, make sure you test it with a chip that you don't really care about and you can throw away. For the standards compliance, this is NFC Forum Type 2 tag operation compliant. So if you go through the NFC Forum, you have to pay for a lot of their standards, but this is adhering to their standard. It's a standard NF text record type, and then we are ISO IEC 14443A compatible as well. So just making sure that it's standardized for the actual data and the way we're interacting with that data, plus adding those additional headers and the other stuff inside of there. You can see more information about the in-depth implementation And we have an example integration here as well. This is effectively just a small portion out of the larger reference implementation. So take a look at this. You can see there's a write option, there's a read option, very basic version of it though is shown here. When you go through the reference implementation, you'll notice there are some required packages. PyScard is what I use because it's all written in Python, and that's just the NFC implementation that you can get in Python that makes it easy to interact with NFCs. Obviously, logging, JSON, argparse, CSV. So very basic packages are required. It doesn't really get you too far outside of a comfortable level for yourselves. And then the system requirements, NFC reader requirements are on there. And then Python 3.6 or greater, that's just for that PyScard package itself. I didn't put any test cases in here just because this is an informational chip. However, you can go through, create your own test, and utilize the reference implementation in order to test out anything that you want to do with these NFCs and make sure it's adherent to the actual implementation that we were showing. Both repos are available in there as well. And then I've already gone over the data protection, but just quick recap, you do have the option to lock those tags after you write. There is no encryption, so keep that in mind. The data on these NFCs is human readable and it is public. That's something that a different implementation could cover, but this chip is not covering encryption of the NFC data itself. There's no physical tampering detection. Some of the really fancy NFC chips out there can actually do physical tamper detection, where if you try to peel apart the NFC or you try to mess with it in some way, shape, or form, it'll brick the NFC or the NFC will end up with an error message. That's not covered here either. We rely on the Chia offer security model. So when you're looking at utilizing single-sided offers on these, or you're packing in other types of offers, you are relying on whatever type of offer file you're putting in there. Luckily, Rigidity created a chip recently for single-sided offers to make them securely accepted. The issue with single-sided offers, obviously, is that you're sending half of a transaction and you're saying, hey, give me this stuff. And there's no way to ensure that that NFT goes directly to the user unless the wallet supports something like a secure single-sided offer. The CNI shortcode implementation is going to be read-only. So nobody out there is going to be able to write to the CNI database for these offer shortcodes. It's only going to be CNI who could ever write to it in case we want to implement this in the future for our own purposes. And then, of course, 32-byte codes are for enhanced entropy to protect from collisions and grinding. And that's just the reason we went 64 character rather than something smaller like 5. And just to reiterate, this data is publicly readable. The lock tags cannot be modified. So if you do go through and you use this and you lock a tag, you're locking it. It can definitely mess things up. And then the other thing is that the physical damage to the chip can corrupt the data. So if these things get waterlogged, if they get damaged, that can brick what's going on. Keep that in mind. Make sure you keep them secure and you be mindful of whatever use case you have so that physical damage doesn't brick whatever your actual use case is. But yeah, I know I got a bit into the weeds there, Dan, but I want to open the floor, see if there are questions, and see if we can touch on any specific aspect.
Yeah, all good. Thanks. Um, I'm wondering, did you mentioned the locking thing a few times. Is this coming from experience by chance?
Yes, it is. Yes, it is. When I was first messing with this thing, I just created it real quick, and I was like, "Oh, it'd be cool to be able to lock it." And at first, I was actually doing a password protection rather than a full lock. So the code I had in there just automatically assumed, "Yes, I want to do this. I just want to do this." And I swapped from passwords to locking, and I bricked a number of NFCs right off the bat just because I wasn't paying attention, and it was automatically locking them all. So yes, I have a
Whoops.
number of them, and I actually just I keep them around, and they just say locked on them, so that I can I can test them out. Oh,
Oh, you
no,
just write it
no.
locked on?
Yeah, I just write locked on them. Oh, that was upside down. There we go.
Nice.
So then I know, okay, hey, that one's locked. I can't use it.
Right. Um, so on that note, are you able to share with us any actual products you're using these in or planning to use them in? Or is that a
I
secret?
I can say that there is something in the works, and we at CNI have a proof of concept, I will say, that we are testing out and should have ready for an event in the very near future.
Oh, I wonder what that could be.
I know. I think that's enough breadcrumbs.
Yeah. Okay. We'll just leave it at that. Yeah, this chip is really thorough, and it occurs to me this may be the first chip we've had that's actually about a chip. So congratulations on that.
Thank you. Thank you. A little chipception.
That's right. Brandon, do you have any questions?
Yeah, I have a couple. So you mentioned that one of the use cases is for verifying the authenticity of a product, because you can put the NFT ID on an NFC that is attached to the product. And I'm wondering, is there a risk that someone could um, create a fake product and then just put the same NFT ID on that with an NFC tag?
Yes, absolutely. And that's something that, making sure that in the future, some future implementation, the chip does actual signing would prevent against that. But that is definitely a potential security exploit is somebody creating an NFC, adding this data to it because it's all deterministic, it's all public data. And yes,
And then the other thing I saw in the example above that it's using the NFT ID with the NFT1 prefix.
Mhm.
I'm assuming that the actual data is in hex instead.
No, it's actually all human readable as you see right there. The reason I did that is so you could scan it with something like NFC tools directly on your phone app and be able to see it. I wanted to make sure that it's quick and easy for other implementations to take on. And if you, yeah, there are some other ways I could have done it to encode it directly in hex, but then it makes it a little bit more difficult to actually read the data off the chip in that point, in that regard.
Well, I don't mean like the bytes directly. I mean using like the hex characters instead of the ECH32 encoding.
As you see it, there is how it is written to the chip. And as you mentioned, it's actually in bytes on the chip.
Okay. Um, how do you know when to stop reading the NFT ID if it's encoded like that? Because the length is variable, right?
No, NFT ID length is dynamic, or sorry, deterministic. It'll always be 64 character.
Even when it's encoded to BECH?
In this format with the NFT1, it'll always be 64 character.
Okay, didn't know
Yep.
that. And then there's one more thing I forgot what that was.
It's good to have standards.
Yep.
That's it. Yep, that's all I had.
All right.
Well, it sounds like you've thought this really well through, and there's a lot of really exciting use cases for this. So it's great.
Absolutely.
Yeah, it's great to see this chip come out. Um,
Yeah. Yeah, I'm really excited to see, what the community does with it. Yeah, I took some inspiration from Cass with his fairy door project and being able to interact with things in the real world. I thought that was really cool back then, and I'm just hoping we can see some other cool implementations along those lines and keep building upon it.
yeah, sure. Actually, one thing that occurs to me is if someone wants to write their own standard, can you kind of forecast what that might look like? Do you think they would just change one or two things within the chip? Like, for example, the 64 character length or something like that, and keep everything else the same? Is that kind of likely uh, for like a version two or whatever the number is going to be?
I would say that would be one of the most common and probably just errata at that point if somebody says, hey, I'm going to be implementing it, but I want this length of a code. This is my version identifier. So they might increment the version identifier or change the version identifier slightly so that it can cover their instance of the offer shortcode implementation. Other than that, I would see a more radical change to something like Brandon and I were talking about, where the chip itself might do the signing in the future. That's what I would see as a more radical step in the future. The other thing that this does not cover that we didn't discuss is that there's room for one NFT ID. And so that's something else that the community might take over and do something else with is should it be one NFT ID? Should it be something else that's stored inside of there? I added a single NFT ID just for POAP purposes and different giveaway purposes along those lines. I think that's kind of the low-hanging fruit for this type of implementation to get a NFC standard out there. But I could definitely see, potentially even integrating with like the Fusion Zoo standard, where you can still use a single NFT ID, but that NFT might contain a whole slew of other NFTs. And wallets would need to know about that so that they can properly interact with the blockchain and go from, hey, here's my single NFT, let me process on chain to get the rest of the NFTs.
Got it. Thanks.
Mhm.
Okay, so I guess going forward, after this chip is finalized, if anyone does want to do a new standard, as long as it's just going to be a line or some, or maybe a couple line change, we could just add it as errata. And if they want to make some more substantial changes, we'll just ask them to make their own chip. They can always just copy the majority of yours, but
Exactly.
that'll
Yep.
that'll
Yep.
probably work out better. So,
Yeah, and I believe we now have sorry for the quick scrolling for all those out there. I believe we now have, oh, I thought we had an extends section on here as well or something along those
oh
lines.
yeah,
Yeah, I might just need to add it to this one. I might have pulled an old version of the template.
oh actually no, that is right. Requires, replaces, and superseded by.
Okay, cool.
Yeah,
But yeah, so it could just be somebody saying, hey, this requires CHIP-47. Here's the additional information associated with it as well.
yeah, that would work too.
Mhm.
Okay, so do you feel that you still have more to go with writing this chip? I mean, it looks pretty thorough. So are you pretty much finished with it?
Yep. It is ready to go out into the wild and let people test.
Cool. Okay, so let's bump up the status then to review, and we'll get reviews in and push it along from there.
Perfect. Thank you.
Okay, Brandon, nothing else?
Thank you for the presentation.
Yeah,
Yeah, thanks.
absolutely. Thank you
Thanks
as
for the
well.
presentation. Very exciting. Okay,
Well,
take
have a
care,
great day,
guys.
all.
See ya.